This video just pulls together all that we've learned regarding the Lewis structures and how to draw them, the 4 rules that go with that, finding shape or geometries within that Lewis structure you build, and designating bond polarities in it. Remember, finding shapes and bond polarity is an atom thing. You have to look at a particular atom and determine the geometry around it and the bond polarity around it. So let's start with PCl3. I guess we'll do PBr3. PBr3, let's look at the Lewis structure for it. We know the first thing is to determine the number of valence electrons. That's always what we do first. So we take the phosphorus and we look at the periodic table and we see where it falls. It's 5 steps in from the left, so we say 5 plus, and bromine 7 steps in. There are 3 of them, 3 bromines, so we have 26 electrons that are the number of valence electrons. Just again to remind you, you can look at the periodic table and know where these fall as elements. Phosphorus was 5 steps in from the left in the periodic table in the 3rd row, and bromine was 7 steps in from the left. So 26 electrons. The next thing we do is to find the middle, define the middle, and then frame around it. So we took phosphorus because phosphorus is the greatest need. It has 3 steps before you get to the nearest noble gas. You have to go 3 steps to the right to get to the nearest noble gas. Bromine only needs 1 step to get to the nearest noble gas. So we put this frame together. 3 bromines around the phosphorus. Moving on to the 3rd step, we try to add those valence electrons that have not made it into the frame already. The ones that are still needed. So we can look at our frame and say, oh, there are 2 electrons in this bond, 2 here and 2 here. That's a total of 6. But I have to still add 20 more electrons into this structure. So if we then consider that, I'll wait on step 4, we're going to bring that right down and just add in all the electrons. How many? 20 more that need to be added to this frame. We start at the outside and work in. So with bromines, we're going to start there. So each bromine, we can put 6 dots or 3 lone pairs around because that would give us 8, and we appreciate that. 2, 4, 6, and don't forget, we still have the remaining bond. I've reoriented this. This bromine is this one here. We just turned this. So the bromine has 2 electrons, already had those. Now 4, 6, 8. And we move on to the next bromine. 2, 4, 6, 8. And then the next bromine. 2, 4, 6, 8. But we haven't added enough. We've added 6, 12, and 18, but we have to add 2 more. So we're going to put those on there. Only element we can add and we can put it on is the phosphorus. So we've finished step 3. Now step 4 says this. Drop down lone pair electrons if needed. You say, well, what lone pair electrons? Off of any of these atoms, if there's one next to it that doesn't have 8 electrons around it, we can drop lone pairs down. So let's go and look and see if we need it. Well, this bromine has 8 electrons around it. 2, 4, 6, 8. This bromine has 8 electrons around it. 2, 4, 6, 8. And so also this bromine. And the phosphorus is fine. 2, 4, 6, 8. So it's not needed here. So we can stop. This would be our final Lewis structure. Now that's great, but we also wanted to talk about finding the shape. So you don't mind, I'm going to go ahead and add, I guess, 5 as our next step for finding shape, because it's often part of the story of Lewis structures. So to find shape, we have to remember an equation. The group number is equal to, I'll put it down here, number of atoms off of that particular one you're finding the shape around, plus number of lone pair electrons. So the group number is equal to the number of atoms and lone pairs off of a particular atom. Again, we said this is about a particular atom. So we can pick anything in here and ask what is its geometry. We need to know the number of atoms and the number of lone pairs off that particular atom we pick. So let's pick the phosphorus. The phosphorus, if we pick P, has 1, 2, 3 bromines off of it, and it has 1 lone pair. So for phosphorus, the group number would be 4. And 4, we know from the notes that are in Schoology, is tetrahedral. So that's number 5. And then last, just to maybe also talk about bond polarity, don't forget it's all about electronegativity differences. Electronegativity differences, and we said that increases up and to the right in the periodic table. So let's look at bond polarity for phosphorus to bromine. Phosphorus to bromine. We can say phosphorus, I'm just going to kind of put it kind of in the periodic table, is to the left of bromine, which is down but to the right. And so it's part of some halogens. Anything to the right is going to have a greater electronegativity. Now it's further to the right than it is down. So we'll put bromine as more electronegative. What does that mean? It pulls electrons towards itself. This bromine, this one here, pull electrons away from the phosphorus. And you guys remember in class then we had, for our amino acid project, we said then the bromines would be partially negative because they are more what? Electronegative. They pull electrons in that bond that's shared slightly towards itself. And by extension then, this phosphorus would be partially positive. And that's it. I hope that video helps. Just maybe think of adding to your 4 rules for drawing a structure 2 more so that you can determine on the test the geometry around a particular atom. You have to know the number of atoms and the number of lone pairs off that atom you're finding the geometry around. And bond polarity. It's all about electronegativity differences. Whoever is more electronegative is in this sigma bond pulling and is therefore partially negative. Bye-bye.